Okay, this is the graph of y equal sine of x divided by x. So we know that sine of x is kind of this graph that goes like this. When you divide by x, it changes the graph a little bit. In the middle, it goes up to a y coordinate of 1. There's a hole right there. And you might notice that if you plug 0 in for x, the sine of 0 is 0 divided by 0. Usually when you have 0 divided by 0, that creates a hole in the graph. In this case, it's at the point 0, 1. Put pi in here. Sine divided by sine of pi is, what's the sine of pi? Think about that.
Oh,
0. Yep. Sine's your distance up or down, remember? So it's 0. So you'd end up with sine of pi would be 0 divided by pi. 0 divided by pi is 0. So that's the point pi 0. Now what we're going to start doing is asking you limit questions. Questions like, what is the limit of sine of x over x as x approaches 0? From both sides. That means when you're to the left of 0 and to the right of 0, what is this expression getting really close to? 1. Yep. You're right up here. When you're to the right of 0, you're right there. That would be called the right-hand limit, which would have a little plus right there. When you're to the left of 0, you'd be up right there. The way we'd write that would be a little minus right there. If we don't put a plus or a minus, that means we're looking at both sides. And the y-coordinate gets very close to 1. Even though there's a hole there, the limit still approaches 1. How about the limit of sine of x over x as x approaches pi? What's that going to be? So I'm getting very close to pi. There's no plus or minus, so I'm going to look on the left side, which would put me right there. And on the right side, it puts me right there. As x gets close to pi, and keep in mind that this is equal to y. So what's y getting close to? 0. Yep, here's 0 on the y-axis. So what I'm trying to want you to notice here is that it doesn't matter if there's an open circle or a closed circle at the given value of x. It only matters what it's approaching from the left and the right sides. The limit is what it's approaching, not what actually happens at the point. Like if I said, what's y of pi? That would mean what's happening, what's the y-coordinate when x is exactly pi? And you'd say 0. If I said, what's y of 0? That means what's happening when x is exactly 0. What would you put for that? Undefined. Good. Yep. So when you write it like this, or sometimes it's writing f of 0 or f of pi, that means look right at that x coordinate. Tell me what's happening. When you're doing a limit, you're approaching from the left and the right. Now the new thing we're going to start doing today, in lesson 2.2, is to find the limit of a graph. Let's keep using sine of x over x. Now we're going to approach infinity. So where would I look on the graph if x is approaching infinity? Which direction? Can you point the direction I'd look? Okay, I see several people pointing out here. Yep. X gets really big as you go out to the right side. So as the amplitude's how high and low it goes, as the amplitude gets smaller and smaller and smaller, what do you think that y-coordinate's getting close to? Yeah, 0. And if we approach negative infinity, where do you think they want us to look now? If x is approaching negative infinity. Yep, some of you are going like this. That means you're looking out this direction. X gets really negative out this way. So as you go out to the left, again, it's going to approach 0. And you notice no matter where you look on the graph, the right side matches the left side. So this is what type of a graph? Even. That's a little review from the first chapter. This is an even function. Any questions about any of those limits?